There you go.
Sorry.
That's okay. Yeah. Okay. Oh, sec. Okay, well, I think it's time that we can start. So welcome everybody again to the Center of Educational Neuroscience seminar. I'm Dr. Jo van Heuwegen, and I'm one of the Center of Educational Neuroscience members. And it's my great pleasure to welcome Dr. Hiwet Costa today. I just wanted to introduce Hiwet a little bit. So Hiwet already, some of you might know her already from a long time ago, a couple of years ago. You were at the Center of Educational Neuroscience whilst you were doing your PhD. And so it's great to see that you obtained successfully your PhD in educational psychology. I know your research interests focus on the development of cognitive intervention programs, with especially focusing on prevention of learning difficulties in mathematics. Hiwet is also the co-founder of Happy Mind Training, and that's an organization that supports families and professionals working with children with learning difficulties such as Down syndrome and other learning difficulties. Currently, Hiwet works as part of a content development team at Smartick, which is an online platform for children to learn and master mathematics. And she also collaborates with the Numerical Cognition Lab at the University of Malaga. And today she's here to present to us a validation study related to the first Spanish online Dyscalculia test. So thank you very much, Hiwet. I'll give you the floor, and we obviously welcome any questions at the end of your talk.
Thank you very much, Jo. So hi everyone. Yes, today's talk will be on the first Spanish online and free Dyscalculia test. As Jo said, I used to live in London. I've done part of my PhD with Jo and my postdoc, and after a few years working in London, what happened is that I fell in love with Malaga and Andalusia. So in a few months, I decided to move there, and very quickly I started to collaborate with the Numerical Cognition Lab at Malaga University. I've been very lucky because in the same period, Smartick, which is a private company, they contacted the Numerical Cognition Lab, the leader of the lab, Professor Javier García-Orza, and they asked to collaborate at the Dyscalculia test project. So they wanted to create a test, an online test, to assess mathematical abilities in children, and the idea was to create a Dyscalculia screener, so a fast test, a quick test, and their idea was also that this test had to be free of charge for everyone to use. So 2 years ago, this project started as a collaboration between Smartick and two public Spanish Spanish university, the University of Malaga and the University of Valladolid. Before I present the test, I wanted to talk a little bit about Dyscalculia and Dyscalculia in Spain. So as you probably know, dyscalculia is a learning disability that affects the development and performance of arithmetic skills. We can say that is a little known learning disability. So here in Spain, for example, sometimes it's called dyslexia for numbers, and even if the prevalence of dyscalculia is estimated to be around 7%, which is the same of dyslexia. It is an unknown learning disability. So I will show you a silly quick test that I made. And I saw in a presentation of Professor García Orza. So if you try to Google dyslexia in Spain, you have 7 million results, and if you try to type dyscalculia, you will find 1 million results. Yet this is a silly test, but can show you that there is quite a big difference between how much people, how much information there is online about dyslexia and about dyscalculia. When we started the project, this 1 million was only 800,000. So in 2 years is growing the awareness of dyscalculia. Given that I'm doing this talk for a UCL research group, I also put the results here. If you Google dyslexia and dyscalculia in UK, and here you can see that the difference is huge. So you have almost 75 million results for dyslexia and only 4.5 million for dyscalculia. So it's sure that there is a difference. People in UK, they know really well what dyslexia is, but dyscalculia is different. People don't know, people are not very sure. And same happened in Spain. I would say that the situation here is worse. So let's continue talking a little bit about dyscalculia. So different studies shows that dyscalculia is a really heterogeneous disorder. Children with dyscalculia indeed can have problem in different aspects. So reading, writing of numbers, remembering number facts is a big problem for a lot of children with dyscalculia. Then we have calculation problems, mathematical reasoning, and then you can find also deficits at more general level, like working memory deficits, speed of processing, visuospatial skills. So it's not easy to identify one profile of dyscalculia. Some study found that in primary school children there are different profiles. And also, for example, a couple of years ago, we published a paper about heterogeneous group in preschool children at risk for dyscalculia, so lower achievers in mathematics. And we found that even in young kids, in preschool kids, you can find different subgroups. So the fact that it is an heterogeneous disorder and that there is a lot of comorbidity. So more than 50% of children that have dyscalculia also have other conditions such as ADHD or dyslexia, for example. So all these two aspects makes the diagnosis of dyscalculia very tricky, very difficult, because we don't have a clear profile. So let's see what kind of tools we have in Spain to assess basic mathematical skills. So there are two main, at the moment, there are two main tests that we can use. On one side, we have the TEDdy Math. The TEDdy Math with Spanish standardization is a test for 4 to 8 years old. We need about 1 hour to test a child. Of course, it depends on children's ability. And I would say it's quite a childish test. So there are a lot of manipulatives that you have to use to assess the child. And when you assess a 7-8-year-old, usually they're not very happy, because they see that the material is more the target for this material is more 4 or 5 years old. Then we have the TIMA-3 with a Spanish standardization. This test is for 3 to 9 years old, from 3 to 8 years and 11 months. And we, based on what the manuals say, we need 45 minutes, but from my experience in UK and in Spain, it depends a lot on the child and on their abilities. So these are the two tests we can use. There is also another one that I put here, is the PIE. With this test, we have a different version for each grade. Here we can assess some mathematical skills, but is more related to the Spanish curriculum. So yes, we are not assessing basic numeracy skills such as ANS or subitizing. It's more related to what children learn at school here. So we have done, of course, this review of the tools that there are in Spain before we started our project. And we decided that, as I said before, we wanted to do something different. So these are paper and pencil tests, and we want to create an online one. These are more tests to be used from professionals. We wanted a test that can be used from families, professionals, or teachers. These tests are quite long because, of course, they are a complete assessment of early mathematical skills. We wanted something quick, a screener, about 15 minutes. And then this is also a big difference. It is free. The idea was for this test to be free, so everyone can use it. Public schools can use it without problems because there is no money problem. So we started from a review of the assessments that there are now in Spain, and also other assessments like the Dyscalculia screener, the UK Dyscalculia screener, and some tests like the early numeracy test, which is a test that comes from the research. Is not published, but there are strong validation studies. And then we also did a review of the literature on dyscalculia and dyscalculia assessment. And based on this, on all this review, we decided that we wanted to include in our test tasks in tasks from 3 different areas of numeracy. So the first one, the first area is the number sense. So research shows that children with dyscalculia have problems with the representation and handling of quantities. So we decided to include in our test a task to assess subitizing, which is the automatic and immediate recognition of small set of objects. Here in this test, we used dots, 1 to 4. So children, some dots appears on the screen. Here you have an example, and you have to select the number. We have to use the digits because it was not possible for the children to speak and the system to recognize correctly the voice with accuracy. So we have to find a way, and that's the solution that we adopted. Then there is the approximate number system. So here, before, with the subitizing, is the recognition of small quantities without counting. With the ANS, we are talking about big quantities, about large quantities, and the ANS is the cognitive system that allows us to perceive and discriminate approximate large numerosities. So here you can see an example. Then if we have time, I can show you the test, and I will send you, I will give you the link anyway. So here, for example, there are some cards. When the child clicks the play button, the cards rotate, and you can see that on one side there are more dots, and on the other side there are less dots, and children have to click where there are more dots. Then the second group of tasks are the numeracy skills tasks. So we are in the verbal symbolic domain now. Studies shows that children with dyscalculia show problems with number knowledge in general, so impaired mapping and transcoding between number words, digits, and quantities, poor understanding of play value system, impaired access to a mental number line, and we know that the mental number line is like a really strong predictor of mathematical performance. And then there are difficulties in counting. So we included 6 different tasks in this area. We have in the number knowledge, we have 2 different tasks, one for digit recognition and another for comparison of numbers. Then we have the number line task, and also here we have 2 different number line tasks. In the first one, children have to estimate the difference between numbers on a number line. And then the second one, they have to position number on a number line. So here there is an example, the second one. We have the number 25, and they can click on the number and drag it on the number line. The first one is just a very common task is used also in the TEDI math, also in the TEMA, for example. So they see one number, like number 5, and then I will show two numbers, and you have to say 2 other numbers, and you have to say if number 5 is closer, for example, to 2 or 10. Last, counting. So we have one task that is the counting of objects. So a few objects on the screen, and they have to count and say the total number. And the second one, in the second one, children have to complete a series of numbers. So there are a series of numbers with some missing numbers, and they have to complete, to find the rule to complete it correctly. Last group. So we say first number sense with A and S subitizing, then all this numeracy, symbolic numbers related to number knowledge, the mental number line and counting, and then we have the arithmetic task. Children with dyscalculia are characterized by severe inability to learn arithmetic, and also persistent. So we included 3 different tasks, one of addition, subtraction, and multiplication. For the multiplication, children, the multiplication task is not administered to children in 1st grade, because here in Spain they don't do multiplication in 1st grade. So let's see a little bit a little bit of information about our validation study. So 737 children participated to the validation study, to the last part, to the main validation study, because we also did a pilot study before. So these are the children that will be used. The result from these 737 children will be used to do the standardization tables. These children are in 1st, 2nd, 3rd, and 4th grades. Children with special education needs has been excluded from this final sample. And we did this validation study with tablets. In the pilot study, so the pilot study was a short study where we try also to assess the usability of our test. So we tried, for example, to use the tablet and the computer, and we saw that there was a significant difference as expected in reaction times. So at the end, we decided to do all the validation, the main validation study with tablets. I said before that dyscalculia is a little known learning disability here in Spain. Usually teachers and professionals don't know much about dyscalculia. They don't know how to assess, and they don't know how to program an intervention. When we assessed, let's say 737, but it's much more, because if we also include the pilot study, is more than 800 children. We only found one child with a diagnosis of dyscalculia. And this is not because there were no children with severe mathematical learning disability, but because, as I said, it's really difficult to find a child with this kind of diagnosis, because people don't know what dyscalculia is. And I think this is an interesting data, interesting result. So about the method, we assessed children in 3 different areas of Spain: south, north, and the center, and Madrid. So different schools, public schools and private schools. We did the test in the children class. Was really easy because each child has their tablet and their headphone, and they didn't need any instruction because all the instructions are in the test. So at the end was quite fast to administer. And we did this study in the academic year 2018-2019, and we published it a few weeks before the coronavirus situation. These are some results. So here you can see the descriptives for accuracy and reaction time for in the 11 task of the Dyscalculia test. The accuracy is between 74% and 99%. This is the percentage of correct responses. In the pilot study, we also did an item analysis to exclude the items too difficult for the typically developing children, because so the item with an accuracy below 50% has been excluded. This is because the idea of this test is to be a screener, and we need these items. We need to include items that can help us to discriminate easily between children at risk and not at risk. And if an item is so difficult for a typical developing children, doesn't help us to distinguish between the population at risk and not at risk. So the children performance in terms of accuracy and reaction times in this 11 task included in the test, significantly correlated with their chronological age. So I have some graphs here. In the top row, you can see the accuracy. This is for the ANS and subitizing, and bottom row, the reaction times. Here we have the number line task, the number comparison, and this is the oral to Arabic. Always at the top, there is the correlation for accuracy and bottom reaction times. And last, three more. So here we have the second number line task, counting sequences, and then the addition, subtraction, and multiplication, all the arithmetic. Always here, addition, subtraction, multiplication, accuracy, and on the other side, the reaction times. So we calculated with the Chromebox Alpha the reliability, and here you can see the reliability results for each grade. Yes, taking into account the accuracy and reaction times. And then I wanted to show you a result for the criterion validity. So we had So one option was to assess the children with our test and with the TEMA, for example, or the TEDIMA. The problem was that use the TEMA or TEDIMA with a lot of children is very time consuming. And so we didn't have enough time and money at the end to do this kind of to calculate our criterion validity this way. So we decided to take the pipe. Within the pipe there are two subtests. One is numbering and the other calculation. So we decided to consider the scores for these two subtests and to create a score of numbering and a score of calculation of our Dyscalculia test. So the calculation, of course, was with the arithmetic, 3 arithmetic tasks, and then we created a numbering score with all the tasks in the second area. So when I say that before, I called numeracy, and then we correlate this score and with scores, and we see that there are significant correlation between numbering calculation of the pipe and numbering and calculation subtest subscores of our test in all grades. So then we have to decide the at-risk criteria. Researchers of mathematics learning disability commonly use very different cutoff scores to determine which participants have dyscalculia. So there is no international rule on a clear cutoff to be used. We try different cutoff, and then we decide to use the percentile 10. Then we didn't want to create one score for our Dyscalculia test, because we're talking about very different tasks, assessing very different abilities. And we say that children with dyscalculia can have really different profiles, so they can have problem on one area but be good at other kind of mathematical tasks. So we didn't want to put all this information to get mixed all this information with creating one total score. So at the end, looking and analyzing our data, we decided to use a criteria of 5 tasks. So children that are at or below 10 percentile in 5 of our tasks receive a report of at risk of dyscalculia. What we did, it's also so we wanted to test our test with children with dyscalculia. The problem is that there are no children with a diagnosis of dyscalculia in Spain. So of course this made our work really difficult. So what we have here is a group of children with severe difficulties in mathematics. In public schools here in Spain, there are some centers that can identify children with learning disabilities, with learning difficulties. So some teachers within the school recognize these children having problems, and usually what they do, they send them to association of children with dyslexia. So this is what happened. So we found a group of 26 children of with severe mathematical severe problems in mathematical learning. We assessed them with our Dyscalculia test, and we found that 24 of these children were at risk of dyscalculia, while 2 were not at risk. So even if these children have not diagnosis of dyscalculia, we can say that in this case, with this kind of children with math learning difficulties, there is a sensitivity of 92%. We are also doing in the numerical cognition lab, we're doing a research with children with dyscalculia. So what we're doing now is we are doing the diagnosis. So children come, they are at risk. We do a complete assessment of IQ, language, mathematics, attention, and then at the end we give family a report. And so we are doing a study to do a more complete validation study with children with dyscalculia, and maybe we will show you the results soon. So this is the team. We have from Smartick, Daniel and Patricia. From Malaga University, the Professor Javier García Orza, and from Valladolid University, the Professor Jose Maria. I wanted to show you, I have here. I wanted to show you I hope you can see what I'm showing you. This is the report of the test of dyscalculia. So this is what people get when they finish the test. So here the result can be at risk or not at risk. Then there is a comment here where we say that this is only a screener. So with 15 minutes without assessing IQ, language, attention, you can't do a diagnosis of dyscalculia, and this is really important. So we suggest, if they are at risk, we suggest to contact a professional to have a complete assessment of mathematical learning disabilities and abilities, and in general of their cognitive skills. And then we have a profile here. So here we have the number sense tasks, the numeracy, and then at the end, the arithmetic skills. As you can see here, we have the here we show the percentile for accuracy, and here are the reaction times. And this is quite important because in literature shows that some children with dyscalculia, they have problem with accuracy, but they are also slow. And if we are assessing, for example, for children in grade 4, usually they can do this kind of task. So if we talk about counting, for example, children, 9 years old children, most of them, even if they have dyscalculia, they can count correctly, 1 to 16 dots or objects. But from our test, we can see that they're slower compared to their peers. So this is why we wanted to include accuracy and reaction times. And again, we didn't mix them. So you can be at risk for accuracy, or maybe from the results, you can see that you don't have big problems in accuracy, so you can do the task, but you are really slow in some of the tasks. Then here you can see, you can't see here, but in the second page we have like a detailed description of what, for example, the different tasks are assessing, and an explanation of the percentile and what percentile means. So parents, for example, can do an interpretation of the report. Yes, that's the report that they get. Back to the presentation. So thank you very much. If you want, I can show you some of the tasks. I can show you how the task look like, and I'm here if there is any question.
Thank you, that's great, and thank you for for representing this. Are there already any questions, or do people want to have a minute and actually see the game? So Caroline is asking where the talk would be online. The talk will be uploaded on the YouTube channel later on, probably tomorrow, Caroline. So you'll be able to find it there. And it's always in Matt's updates. Oh, you mean
the screener? I show you. I will put here the link. Oh yes. Also, I wanted to say that this is the validation. We always have the validation with Spanish children, but now the test is also, you can find the test in English. So in the manual, we say that you can take the test in English, and we are assessing really basic skills. So theoretically, if you assess A and S in Spanish or English children, the difference shouldn't be that big. But the validation sample, so they just translated the test. Of course, we would love to do a validation study also in UK. So if there is, or in other parts of the world. So if someone is interested, I will put the link.
Yes, maybe later, which we can, if you share the link, then I'll make sure that Matt distributes it, if that's okay with you.
Please, if you try, just to try it in the name, if you can put like something, so I can, because I check the data sometimes. So if you can put test, for example, I know that
we're not a real participant, that we're not a real child, for
yes.
example. Yes,
this will help me a lot. Okay, I put the link here anyway. So
okay. So Elisa has a question around whether you had any baseline activity for the children complete the mathematical test, for example, a test of processing speed for, so because you're measuring reaction time.
Yes, I forgot to when I was talking, I was like, I'm forgetting something. Yes. So before they start the mathematics task, there is a reaction time task. to make sure they're slow, because they're slow in mathematics, and not because they're slow in general, all the, you know, the internet connection or something. So there is this, is that there are some dots on the screen, and children have to click on the dots. It's very quick and easy.
Okay, so you've got your baseline.
Yeah, we have the baseline. Yes, what we decided to do is that we didn't want to. We didn't correct the reaction time score for the baseline. What we did is that if the child is slow, below 10th percentile on this task, in the report, there is a comment saying the child performance in the reaction times is really low, so this may affect the results of the test in terms of reaction times. Something like that. You can check it. So we make sure they know that this can affect the results.
Thank you. Camilla's got a question around whether the children received any feedback when they finished the test. And I think maybe my own question would be there in terms of, you know, motivation. Did you do any? Is there anything in the games or in the app?
So at the end, so the I don't have the final screen, but no, they don't have a feedback to say if you've done good or bad. It's just Smartick has these two characters, are two monsters. So these two monsters appear on the screen and they say great job, and I don't remember exactly what they say, but it's something fun and with a lot of colors. And after each task there is no feedback. There is no feedback because this can affect I mean, if they receive a bad feedback and it's difficult for them to keep going on the task without any effect on it.
Absolutely. Are there any other questions? I've written down the questions of 5 tasks, but I can't remember what my question was. I think it shows it's Thursday afternoon. I think it was around you selected 5 tasks.
Dyscalculia.
Sorry.
No, but it's not age. What they might not be supposed to. Now, this Dyscalculia test is from 1st grade. It's from 1st grade, so 6 to 9-year-old is here, from 6 to 10 years old. So probably before I said year 3 or something like that. Was confusing, I don't know. We try to assess also preschool children anyway. We try to assess 5 years old, so last year of preschool. And we in the pilot study, and we didn't continue because again it was time consuming. With 5 years old, you need one person, one researcher to be with one child. And with primary school children, you go in a 30 children class and they do the test all together. So at the end we did the pilot, and then we stopped with the idea that maybe in the future we can do a preschool version. The test takes 15 minutes. I mean, if you're good at math, you can do it. Children can do it in 10 minutes. If your Dyscalculia is quite severe, you can reach the 20 minutes, but usually it's 15. Yes. Also, yes. The TEMA 3, and I'm answering the question here for the 3 years old test. The TEDIMATH and the TEMA. But they are not Dyscalculia tests. They are like a test to assess early mathematical skills. And yes, they start from 3 years old.
Erica is asking whether there's any sound.
Hi, Erica. Yes, so they I don't know if I will show you, just for example, if this is the task, there is the first, when the task appears for the first time, there is an instruction, so voice speaking and explaining the task. That comes automatically, and then you just do the task and then you go to the next one. I don't know if that was the question.
Yeah, I think so. I mean, I think in a lot of the online, I'm trying to think, athletics, for example, they have like a button that children can press to always have the instruction again. So if they've got problems with reading the digits in this particular task, for example, if they can't read 25, it will read it out to them in terms of kind of to make sure that, is it a number line issue or is it a digit recognition issue?
Yes, so that it depends on the task. So for example, in the digit recognition, you can if you can press a button and hear again and again the number.
Right. Yeah.
Okay. But for example, here in the positioning not, you just do this.
Okay.
And then you go on the next one. But yes, let's see if I have the, no, I have the, I didn't have any ready here.
That's okay. Jane is asking whether the task was gamified to maintain children's motivation, for example, with an avatar. Or
no, we decided to do it quite plain, but it's really quick and it changed a lot because it's really, you have few seconds per task. And so you have the ANS, where is more, and then subitizing, what number is this, well, how many, and then change again, let's go, the counting, the numbers, and so when we went to the schools, children were super happy. So we saw that the motivation levels were really high, so we were happy about that. And children, people from Smartick, so the people working there, they were like, how is that possible? They are so engaged and so happy to do it. And then we found out that probably is because it changed a lot.
I think Clara's question kind of tags onto that one in terms of change and being, so she's asking, is the test adaptive? So how are the items selected according to the child's ability, or is it not?
Okay, so we started from the first version where the items were the same for everyone. And then we started, we excluded the items that were too difficult for some of the, for example, in first grade, we don't show multiplications. And we also excluded few items from the sequence. And also from the digit recognition, because digit recognition with very big numbers is something that they don't understand. And we had different items for the preschool. So for the preschool years, we had addition and subtraction with objects. But given that we didn't follow with that.
So if I understand, so currently in the screener, do all children, regardless of the age, get always the same items? And if you were to repeat it, so you know, say you want to repeat it within 6 months, does the child get the same items, or is there like a
the same? Yeah. And we were thinking to do an adaptive version with like the idea was to use like for example, that you don't have to administer all the items, but the machine based on the performance of the child, select one item or the other. But at the end, this test is that quick, it's only 10 minutes, that my opinion was that I wasn't sure that it made sense to do something like that. I mean, but yes, it's something that is open there.
Yeah, no, that's great. Well, I don't know whether there's anyone who wants to have the last question for today, but if not, oh no, thank you indeed. I wanted to thank Hiwet for
thank you for inviting me
for a great talk today, and also thank obviously everybody in the audience for listening and for providing some really good questions at the end. Hiwet, thank you very much for providing the screener. You know, it was a great talk. Great. It seems like, you know, this very interesting work in using technology in terms of mathematical screening. So thank you. And
thank you.
Look forward to all people in the audience for, again, our Center of Education on Neuroscience seminar next week. Thank you and take care for now. I'll stop the recording.